my name is Masheka Lewis, and this is my presentation for Module 2, Chapter 2, and Chapter 3. Chapter 2 is over sets and whole numbers and number theory, and Chapter 3 is numeration and calculation. Let's go to the first question. Okay, the first question is to construct a three-loop Venn diagram to show all eight elements of U. It then lists the three elements of the following sets. These are our, where's my mouse? Okay. These are what we're looking for and what we're solving for. Now, the first thing we need to know is how to solve this problem is what is a three-loop Venn diagram. So a Venn diagram basically shows all of the possibilities for a section, or by grouping things together to see the possibilities. Now, a three-loop Venn diagram looks like this. Okay, so the next thing we can know to solve this problem is to know what is sets. So if we look right here, it is given us this A, U, A, B, and C. So to construct the three-loop Venn diagram with this, we have to see what each have in common and what all have in by themselves. So we have A, B, and C. This will be our A, B, and C. And then we see what they all have in common and what all by themselves. If we look at A, we see B is by itself, so B will be by itself in A. But we all see that B, A, and C all has D, so it'll go in the middle because they all share. And that's how you construct the three-loop Venn diagram. Now, we also need to know what a set is. These are our sets. Sets can be anything from letters, numbers, and colors. It's just a grouping of things that we have to solve for. Now, to also solve this problem, the last thing we need to know is our symbols. So we have a U and an upside down U. The U stands for union, and you can see the union as OR. It is easy to notice as OR. Next, we have an upside down U called intersection, and we look at this symbol with and. So we see what's in something and something. So let's go to the first question. Let's solve the first question. I think it was better, right? No. Okay, let's construct our diagram first. So we have to solve for 1, 2, 3, 4, 5, 6, and 7. But first we have to construct the Venn diagram. So like I said before, we have to see what they all have in common and what they all have by themselves. Like I said, A, you have B by itself, and B is not shared between anything else but U. But of course, this is just U means but everything in together. So that means A, B, and C is inside of U. So we have B and A by itself, and then we have C and A by itself. So it'll all go in A. But then we see that A have G and C have G. So we have to put this where A and C both have G, but we see that B do not have G, so it will not go into the middle. Now we do see that D is shared between A, B, and C, which means this will go into this little section, which means everything is shared. Okay, now that we have the basics to that, let's solve our problems. Now, here go our 7 problems. Now, of course, we see B union C. Like I said, it's easy to see union as OR. So we have what's in B or C. So within B or C, to solve this, you label everything that is in B and C. B and C. So you have F, D, H, and G, because D and H is shared between everything, so it's F, D, H, and G. Now we have A intersection B, or A and B. So what A and B have in common? So what do A and B have in common? Now A and B by themselves have nothing in common, but they both have D and H in common in all 3. So D and H will be your answer. Now, like the second one, we see B and C. So what do B and C have in common? Of course, we have nothing right here because they have nothing in common by themselves, but they do have D and H by themselves, in all three. Next, we have A or C. So like I said, you label everything in A and C. So that would be B, C, D, H, and G. Now, the A with the line over it, it means everything except A, everything that is not an A. So if we look at this, we see that A has B, C, D, H, and G. So B, C, D, H, and G cannot go into the answer. But we see A and E have nothing to do with A or B or C. So we have A and E will go into A, but we also see B right here, how F is not intersected with A. So F will also go into the problem. So our answer will be A, E, and F. Now we have A and C. So what's an A and C? So we look at A and C, what they have in common. We see G by themselves, but then we see D and H as well. So the answer will be G, D, and H. Now we have our last problem is A or B and C. So what do B and C have in common? If we look at B and C, we will see they have nothing in common by themselves, but we see D and H. So D and H would be part of our answer. And now we have A or B and C. So what's all in A? We have B, C, D, H, of course, and G, because G is in A. So our answer would be D, H, B, C, and G. And that's how you solve this problem. Let's go ahead to the next problem. Okay, this is says to construct a Venn diagram with 12 shapes in the Venn diagram. Then it gives us a chart of what goes into it. So we have C, H, and T, and it said let C, H, and T be circle, hexagonal, and triangle. Right here. And then we have S, L, R, B, and we will let S, L, R, B be small, large, red, and blue. So the first thing we need to do to solve this problem is to construct a cheat sheet for this. So we to let us know that C will be circle, H will be hexagonal, T will be triangle, and so forth. Now this is still a Venn diagram. It's just another type of Venn diagram, but it still shows all our possibilities, which is a Venn diagram supposed to be. Okay, let's go and solve the problem. Okay, like I said, you construct a diagram to help you keep track of everything. Now, for this problem, we have to find out what are we looking for. So let's go to number one. We're looking for L and H. So what is L and H? So we're looking for large and hexagonal. So for this problem, we're looking for a large hexagonal shape. Now it don't give us a color, so we're just gonna assume that it don't matter if it's red or blue. Now let's go to number two. We're looking for C or H. So circle or hexagonal. So this problem, it can be circle or hexagonal. Of course, again, it didn't say any colors. So we'll just say blue or red. It doesn't matter. And it also doesn't say anything about size. So we'll do both small and large. So we'll be looking for circles or hexagons that are small and large, or blue and red. The only thing we're not looking for is triangles. So everything, all the triangles will be excluded. Now we have T and R, which is triangle and red. So we're looking for red triangles. Now this problem don't say anything about size. So we'll look for red triangles, and it can be large or small. Our last is circle and small and red. So S, N, C, and R. So they've given us a specific object to look for. We're looking for circles that are red and small. So we're looking for nothing but small circles that are red. And that's how you solve this problem. Let's go to the next one. Our next one is different number systems. Now, we already Okay, I'm going to put it there. Now, we already know that we have our own number system, which is 1 through 10, and we know how to use it. But it'll be a shock to some people that our number system wasn't always here. In fact, in different areas of the world, they had their own number system, and most of them dealt with pictures like Egyptian, shapes like Babylonian, or letters like Roman. So, to solve this, we'll first have to determine um, I'm sorry, we'll first have to determine what number system we're using. So to solve this, we'll also have to um, multiply how many they give us by our value they give us in our number system. Now, Mayan number system is a little different, but we'll show you that when we get to it. Now let's start with Egyptian. Now, we have 3 pointing fingers. This is our pointing finger, which is 10,000. This is our pointing finger. It just mine is backwards, but it's the same thing. So we have 3 times 10,000, which will give us 30,000. Next, we have 5 heel bones arch. So we'll put 5 times 10 because our heel bone arch is 10, which will give us 50. And now we have 4 vertical strokes. So vertical strokes times 4, so 1 times 4 is equal to 4. So we'll add all these together, and then we'll get 30,054. Now, Roman system. Okay. With our Roman system, we'll have to look at the picture and then calculate it, like we did with our Egyptian. So first is M, and our M is 1,000. So M will equal 1,000. We just have 1, so it'll be 1,000. Next, we have CM. Now, CM, most people will look at CM like 1,000 plus 100 because C is 100. But actually, with Roman system, it's actually a little different. We actually have to subtract the right from the left. So we'll have to subtract 100 from the 1,000, which will give us 900 instead. This is because it has it at the bottom, and then we have to go to the top. So when your M is right here, you have to just subtract it. Sorry, I'm being a little tongue-tied. So it'll be 900, and here go a more simple way to say it than what I just said. Next, we have 3 x's. Our x's is 10, so 3 times 10 will give us 30. Then we have v, 1v, 5. So 1 times 5 is 5. Then we have 2 i's, and I equals 1, so it'll equal 2. Now we just add all these together, and it'll give us 1,937, and that'll be our answer. Next, we go to Babylonian number system. This is actually the easiest number system because they only give us 2 shapes that we have to go by. Tens is this little sideways triangle or boomerang. I always call it a boomerang. And then we have this one, which is a upside down triangle. So we just have 4 10s and then 1 1, which equals 41. Now, like I said, our Mayan number system is a little complicated. Unlike the other number system, with the Mayan number system, we have to multiply it by the place value. Now, most people would just think that you have to just add the 5, add the 6, add the 3, and add 17, but that is actually not correct. We actually have to multiply it by the place value and then add all of them together. So because it only goes to fourth values, I only went to the fourth one. So our fourth place value is 7,200. Our third is 360. Our second is 20, and our first is 1. Now, how the place value go is it goes 4 to 1. This will, our 5 will be times the fourth value, and then our bottom 17 will be times the 1. And then we just work our way down. So our first will be 5 times 7,200. And that'll give us 36,000. Next is 6 times 360. And that'll give us 2,160. Now we have 3 times 20, which will give us 60. Now we have 17 times 1. 17 times 1 is 17. And of course, you add all these together, and it will give us our total of 38,237. Okay, now we have our lattice algorithm. Now, lattice algorithm is basically a multiplication problem. So it's to make multiplication easier. Now, of course, you can do multiplication with the calculator and everything else, but what if you have a test without a calculator and you want a simple way to get your answer? So to do this, you'll use a lattice algorithm. A lattice algorithm is basically a square with your top number on it, your first number's on the top, and then your second number on the right, and then you multiply it each row by itself. You'll multiply the row by each number. And then to get your answer, you'll go from your left down and then left to right. Now let's see an example of this. This will be how it looks. Our first number will go against the top row. Our second number will go to the second to this row. And then to get our answer, we'll go down and then to the left. Now let's go start with the easy one. Our easy one, we have 28 by 32. So we have 28 at the top, 32 at the right. So now we have 8 times 3, which is 24. 3 times 2 is 6. Now with 6, you have to make sure you put the 0 at the top and the 6 at the bottom. Okay. Now you have 8 times 2, which is 18, and 2 times 2, which is 4. Make sure you put the 4 to the bottom and then the 0 to the top. Now to solve this, you add diagonally. So 6 has nothing to add, so your 6 will come down to this row right here. Then you have to add 4 plus 1 plus 4, which will give us 9. So we have a 96 right here. And then we go to the next one, which is 2 plus 6, which will be 8, and then 0. So it'll be 0, 8, 9, 6, and that'll be your answer. We don't have to carry the 0, so it'll be 896. Let's go to the next one. Now we have a 3 by 3. Again, you just do the same thing like you did the first time. So we do 6 times 3, which is 18. 6 times 7, 42. 6 times 2, which is 12. 2 times 3, which is 6, but you'll write it as 06. And then you have 2 times 7, which is 14. Now, the reason you'll put 0 here is because it's basically a place value. I didn't explain that earlier, but I'm sorry, but it's basically a placeholder. So you'll be able to add everything together, so it'll be easier. And then you have 2 by 2, which is 4. 3 by 8, which is 24. 8 by 7, which is, 56. Trying to get it. And 8 by 2, which is 18. Of course, you add diagonally. So you have 4 by nothing, which will be 4. Then you have 6 by plus 6 plus 2. Sorry, I'm getting tongue tight. Which would be 14. Now to do the 14, you cannot put 14 right here if you're not able to. So what you do is you put the first number to the next row. So the 1 will go up at the top, and then the 4 will stay down here. So then when you have your 6 right here, the 6 will become this row, which means it'll be 6 plus 8, 1 plus 8 plus 0 plus 4 plus 5 plus 6, and that'll give you 24. The 4 will go down again. The 2 will go to the next row. So it'll be 2 plus 1 plus 2 plus 1 plus 4 plus 6, which will give us 11. 1, and then 1 at the next row. 1 plus 4 plus 2 plus 0. You'll get 7. And then you bring your 1 down because 1 is by itself. Let's go to the next one. Now we have a 3 by 3 still. So we just do this like we did the last one. So 4 times 5, 20. Sorry. 5 times 6 is 30. 5 times 9 is 45. 9 times 4 is 36. 6 times 9 is 54. 9 times 9 is 81. 4 times 3, 18. 6 times 3, 18. And 9 times 3 is 27. Of course, you add diagonally, so 2 will come down. Then 6 plus 1 plus 8, which is 15. 1 will go up, 5 will stay down. So you have 1 plus 0 plus 3 plus 4 plus 1 plus 7, 16. You'll have 6 down, 1 up. So then you have 1 plus 2 plus 0 plus 5 plus 1 plus 2, which is 11. 1 will go down, 1 will go up. The remaining 1 will go up. You have 1 plus 3 plus 5 plus 8, which is 17. But the 7 will go down, the 1 will go up. Then you have 4 plus 1, which is 5. Oh, that is 5. Sorry. So our answer would be, okay, I just accidentally did a typo. So our answer would be 571,652. Now, of course, you do this the same way. So 2 times 2 is 4. Remember the 0 at the placeholder. 2 times 5, 10. 2 times 9, 18. 2 times 4, 8. 2 times 4, 8. 5 times 4 is 20. 9 times 4 is 36. 4 times 4 is 16. 2 times 3 is 06. 6, but make sure the 0 at the placeholder. 5 times 3 is 15. 9 times 3 is 27. 3 times 4 is 12. Whew, it's a lot of words. Okay, I'll put that right there. So of course you add diagonally again. So 6, come down. Then you have 8 plus 0 plus another 5, which is 3. So 13. And then you have 1 plus 4 plus 0 plus 0 plus 1 plus 7, which is 13. 3 will go down, the 1 will go up. Then you have 1 plus 0 plus 0 plus 2 plus 6 plus 2 plus 2, which is 13. 3 will go down, the 1 will go up. So 1 plus 1 plus 8 plus 3 plus 6 plus 1. You have 20. You'll have the 0, and then a 2 will go to the next row. You have 2 plus 1 plus 8 plus 1. You have 12. And then 1 plus 0 is 1. So this will be your answer. Again, you go down and then to the right. So it'll be 1,203,000. And then you have 336. Now, this one, they want us to do the rounding and the estimate, exact. Okay, I might as well just leave it there. And the exact, basically it wants to show us what the difference between the rounding or estimated with the exact. So to solve this, you'll have to follow the rule of operation, which is, please excuse my dear Aunt Sally, but it is parentheses, exponents, multiply, divide, add, and subtract. Now, you also have numerator and denominator, sorry. You'll always solve the numerator first. To solve it for exact, you solve the numerator first. And then when you get the numerator, you solve the denominator. If you have a problem in the denominator. I always get that tongue tied. And then you divide the numerator by the denominator. Okay, I'll just skip over it. So let's just get the first question. So again, you do the order of operation. You don't see no parentheses or exponents or anything. You do have add, so you'll have to add this first because you have to add everything in the numerator first. You have to start the numerator first. And that'll give us 1,348. And then you have no problem in the bottom. So you'll have to then divide 1,348 by 134, which will give us 10.056 or 10.6 if you round it up. But we're looking for the exact, which will be the 10.56. Now, too far, sorry. Now we'll have to do the estimate. Now, to do the estimate, you have to round up or down by the tenth place. Now, for the rounding, you have to do if it's 5 or up, you have to round up. If it's 4 or under, you have to round down. So we look at the 10th place, which is an 883. Our 10th place is the 8. We see it's an 8, so we have to round up. So it'll be 900. It'll round up to 900. Then this 10th place, we see a 6. It is higher than 5. So we'll have to round up. So this will be 500. Then we have a 3. It is lower than 4. So it'll round down to 100. So our new problem would be 900 plus 500 divided by 100. So we'll solve the numerator first. That'll be 1,400. Our denominator is divided by 100. So then our answer will be 14. Now we just do the exact same thing as we did the first time. Here go another example of what order you go to. So you do the parentheses first. So 5 times 254 first. You'll get 1,270. And then you add that by 523, which will give us 1,793. Then we got to solve our denominator, which will give us 42. Then we'll divide our 1,793 by 42, which will give us 42.96. That's hard to see. So that'll be our exact answer. Now our estimated one. So we have a 5. So we're going to leave it as 5, and then we're going to round the 5 up right here to 300. So it'll be 300. And then we have a 2 in the 10th place, so we'll write that down to a regular 500. And then this is 42, so we can just go ahead and round that down to 40. Now again, you just do the parentheses first, which will give us 1,500. And then we have to add that by 500, which will give us 2,000. Now we divide 2,000 by 40, which will give us 50. 50. Now we don't have any parentheses, but we still have to do the numerator first. So our estimate, we have to do 620 by 430, which will give us 266,600. Now we'll divide that by 293, which will give us 909.89 or 909.90, but we're looking for the exact, so it'll be this one as the exact. Now we do the estimate. We have a 620. 2 is in the 10th place, so This means we'll round down to 600 even. We have a 430. The 3 is in the 10th place, so it'll round down to 400 because it is less than 4. Then we have 293. We have a 9 in the 10th place, so we'll round this down up to 300. And here, so first we do the numerator times the numerator. So that's 600 times 400, which will get us as 240,000. And then we divide that by 300, which will give us 800. Okay, let's go to the next problem. Now we solving for bases. Now there's different bases than the base 10. We're used to the base 10 because of our number system. So there's different bases, like there's a base 5 and there's a base 6. Now to simplify this, the base 5, I have it right here. Base 5 is basically you cannot go over the number 5. Everything and under, when you do your solution, you have to do it under 5. So your greatest number you can have in your solution is 4. And then if it's over 5 or over 6, because it's the same for both, if it's over 5 for the 5, you'll have to see how much that number divides into 5, and then that'll go to the next row, while the other number will go down. While how many is left over will go down. Let's just see how this works. So let's have the first one. Let's move this over so you can still see the rules. Now we do basic adding. So I'm gonna have to move this. These are our problems that we're solving for, so I'm gonna just see it when we get there. So we have a 2 plus 3. This will be 5. Now, like our rule says, we cannot go over 5. So this means this will be a 0, and then our 1 will go over because only 1 can go into 5. And we have nothing left over, which means 0 will go here, and then 1 will go up here. And here go our 1. So now we have 3 plus 1 plus 3. We have a 7. So 1 will go up here because 5 will go into 7 one time, and then we have 2 left over. And now we have 4 plus 1 plus 1, which will give us 6. We only have 1 and 1 because 5 can go into 6 one time, and then we have 1 left over. Now, I always make sure to bring down the 5 because that is the part of the problem. So we'll just bring down a 5. We'll bring down a 1 and then bring down a 5 because 1 is not adding to anything else. So we'll bring down a 1 and then we'll bring down a 5. Now, our next problem is 425 plus 53. So 5 plus 3 is 8. How many times can 5 go into 8, which is 1 time? So 1 will go to our next row, and then 3 will go to down. So now we have 5 plus 2 plus 1, which is again 8. So we have 1 to our next row because 5 will go into 8 one time, and then 3 will go down because we have 3 left over. And now we have 4 plus 1. Now that equals to 5, but we cannot use 5, so we'll put 0 as a placeholder, and then we'll move 1 into the next row. Oh, sorry. I had to do my annotation. So this will actually be 0. Okay. So that will actually be 0. Sorry about the mistake. And then we'll have this as 1. Let's move this. 1 will go to here. And then we'll bring the 1 down. So our answer will be 1,033, and then we'll bring down our 6. Sorry, that's the misconfusion. That will be 10. Sorry. So we're going to move this up. Now we're doing subtracting. So our next problem is 414.5 minus 43.5. So 4 minus 3 is 1, so it'll be 1. It's not over 5, so 1 will go down. And then we have 1 minus 4. Now we cannot have 1 minus 4. So what we'll have to do is borrow it from the next row. So which means our 4 will become a 3, and then our 1 will become 11. So now we have 11 minus 4, which is 7. So how many times can 7 go into 5? And that will be 1 time, and with 2 remainder. So that means 1 will go up here, and then 2 remainder will go down. So now we go to our next row, which is 3 plus 1, which is 4. So 4 will go down, and then because it's not over 5, and then we bring down our word 5. And that's how you solve that one. Now let's do something a little bit more complicated. Now we have 403.5 minus 24.5. This is not complicated. It's just you have to keep track on what you do. So let's erase this. Of course, so this will be 133.5. Sorry, it's hard to write with the mouse. Okay. Now let's do let's just do it. It's not more complicated. You just have to be very neat when you write it. So you have 3 minus 4. You cannot subtract 3 from 4, 4 from 3. So you have to go to the next row. But our next row is 0. So we will have to just go to the next row, which means our 4 will become 3. And this will go to our second row. So our 0 will become 10. But then the 10 is not what needed. So that will scratch out and become 9. And our 3 will become 13. So it'll be 13 minus 4. Like I said, it's good to be neat with it. So 13 minus 4. And of course, it is 9. So what we do is we have to put 1 up here, and then our 4 remainder, because 5 will go into 9 1 time. So now this is back to 10 minus 2. Of course, we know that it's going to be over. So what we have to do is to see how much 5 will go into, 9. Sorry. How much it will go into 9? No, it is 8. I'm sorry. I'm just being confusing. So how much 5 will go into 8? And then we'll have 1, because 5 will go into 8 1 time. And then we'll have 3 left over. So this will be our second row. And now we just add our last row, which is 3 plus 1, which will give us 4. And then we draw down our 5. And that's your answer. Sorry about this up here. I really thought I had that. And that's how you solve this problem, and that's my presentation. Have a nice day.